Hello friends, welcome back to Civil Depth BD. Today I will show you how we can check buckling factor in ETABS. At first go to File, New Model, Use Building Setting, click on OK. Here I will use uniform grid spacing. Suppose for X direction I will use number 6 grid and in Y direction I will consider number 8 grids. Spacing for X direction I am taking 16 feet, for Y direction I am taking 18 feet. Bottom story height I am taking here 8 feet, typical story height I will take 15 feet, then number of story 10. Click on OK. Just save the model. At first go to define, then material properties, add new material, concrete. Here I will name it as C3000. Click on OK. Then go to add new material. This time I will take rebar, grade 60. Click on OK. Rebar 60. OK. Again go to define, section property, frame section. Go to delete multiple property, delete. Select all of them except one property. Then delete selected frame section. Click on OK. Add new property, concrete rectangular. Name it as C30 by 30. Material C3000. 30 by 30. Property modifiers, here I will not change anything because I need to perform this check in service condition. Go to reinforcement. From the drop down menu select rebar 60. Click on OK. OK. Now we can delete this property. Go to add new property. This time I will define beam 12 by 24, material 3000, width 12, depth 24. Property modifiers here for moment of inertia about 2 axis 0.5 for the service condition, 0.5 for the service condition. Click on OK. Now go to reinforcement, select M3 beam design only, rebar 60, rebar 60. Click on OK. Now define section property slab section. I will modify this property. I will name it as slab 6 inches. Slab material concrete 3000. Slab material concrete 3000. Then from here write 6 inches, thickness 6 inches. Click on OK. Now we can model column, beam and slab. Select all stories, then go to quick draw column, C 30 by 30 which we need, then model beam 12 by 24. Now we can draw floor. From the drop down menu select slab 6 inches. OK. At first we will go to base. Here we don't need any slab, so select them and delete them. Now from the drop down menu select one story, select all the joint at base, then go to assign, joint, restraint, fixed support, apply. OK. But I have deleted all the slab, so let's go back. From here at first I have to select one story, This time it's okay. Now select all the joint, go to assign joint, restraint, fixed support, apply, okay. Now go to define, go to load pattern, dead and live load pattern is already available. I will take wall load as super dead, add new load, floor finish, super dead, add new load. Click on OK. Now go to select object type. At first I will select all the beam, select, close. Then I will uncheck beam from the top floor. For the top floor, we don't need to assign wall load. Here we have to assign just the load of parapet wall. Okay. Now go to metric SI. I will select, then go to assign shell load, frame load. Extremely sorry, frame load, distributed, wall load, 6 kilonewton per meter. I will apply. Okay. Here you can see 6 kilonewton per meter load has been applied. Now for the periphery, I will select all the periphery beams. Okay. Then go to assign frame load, distributed, 2.5. Here I am taking, apply. Okay. Now we have to assign load for the shells. So go to select object type, floors, select, close, assign shell load uniform. I will assign live load, right? Here I will assign live load 2.5 kilonewton per meter square. Click on apply. Okay. Now we have to assign floor finish. So go to previous selection, then go to assign shell load uniform. Select floor finish. Then I will use 1.20 kilonewton per meter square. Okay, 1.2 and 2.5. Now, what we have to do, we have to define mass source. So go to define, go to mass source, then go to modify /show mass source, uncheck, and just check mark on specified load patterns. Dead load 100%, wall load 100%, floor finish 100%, but live load 25%. Because the value of live load is less than 3 kilonewton per meter square. If it is greater than 3 kilonewton per meter square, in that case you have to consider 0.50 as multiplier. Click on OK. Click on OK. Now go to define diaphragm, modify. I will consider here rigid diaphragm. So at first I will select this panel, then go to assign shell diaphragm V1, apply. For second story, similar thing. Third story, fourth, Okay. Now what we can do, we can go for mesh. So go to select object type, floors, select close, assign shell floor auto mesh, auto cookie cut. Here I will consider 600 mesh, apply. Okay. Now we can go for load combination. Go to define load combinations. At default design combo, concrete frame design, convert to user editable. Okay. Click on OK. Then we can go for run analysis, or we can at first check if there is any warning or not. But before that, here I will go to define, then load case, add new case. Here I will add a new load case, which is buckling factor. Buckling. Okay. From the drop down menu, select buckling. Initially, we will not consider any P delta. We will go for applied load, dead load 1, wall load 1, partition wall load, for finish 1, then live load. Scale factor 1 for all of them. Okay. Number of buckling modes, here we will consider total 6 modes. Click on OK. So analyze check model. If there is any warning, it will show us. Now, what is buckling factor and how we can understand that our structure is safe? If we go for the theory is lambda. Let me delete this one. We will take another color. If lambda into applied load equals buckling load. This is the equation. If lambda greater than, that means buckling factor greater than 1, in that case we will understand that our applied load is less than the total capacity of the structure. Our applied load is less than the buckling load. That means if buckling factor is less than 1, in that case we have to understand that our applied load is greater than the buckling load. In that case our structure will fail in buckling. If applied load is less than the buckling load, in that case our structure is safe. Suppose here total buckling load, is 100 and we have applied, for example, 80 amount of load. In that case, what is lambda? Lambda equals 100 divided by 80, which is 100 divided by 80. That means 0.8, right? Sorry, 1.25. In that case, our structure is safe because applied load is less than the buckling load. Okay. But if this load, suppose lambda equals, here this is the buckling load and we have applied 125 amount of load. In that case, what will happen? In that case, $100 divided by 125 equals 0.8. That means we have applied more loads than the capacity of our structure. So definitely we have to check that either the buckling factor is greater than 1 or not. If it is greater than 1, in that case our structure is safe. If it is less than 1, then our structure is not safe. So from here I will at first delete all the things. Now go for analysis. One thing to make clear that I am regularly uploading videos related to SketchUp, ETABS and AutoCAD. If you follow the playlist of my channel, you will find all the tutorials. If you forget to subscribe, please subscribe the channel and share with friends. Okay. Now we can go to display, then show tables, go to structure output, other output item. From here I will select buckling factors. Click on OK. Here you can see that all the values are greater than 1. That means our structure is safe. Now if I consider P delta in the buckling load, what will happen? Define. If we take here load case, buckling, modify. If I consider here non-iterative based on mass, or I can take iterative based on mass. 1.2 dead load, wall load, floor finish. For live load we will use scale factor 0.5. Add. Click on OK. Okay. Now go for run analysis. You will see that due to P delta effect, scale factor will be decreased. That means it will increase the chance of buckling. So when you are checking buckling load, don't forget to consider the P delta if P delta is present in your structure. Okay. If not, then we can go with no P delta or none P delta. But if we have P delta effect in our structure, in that case, definitely you have to consider P delta. Okay, now go to display, show tables, structure output, buckling factor. Here you can see previously this first mode, which is the most critical one, you can see previously this value was 17 point something, but now this value has been decreased. That means the chance of buckling has been increased, but this is greater than 1, which is 16.91. In that case our structure is definitely safe. Okay, basically we check this buckling effect when we are designing residential come commercial building, because for the commercial floors we have to assign more heights than the residential floor. In that case, definitely I will recommend to check the buckling effects. That's all for today. See you in the next tutorial. Thank you.